Probability distributions. The probability distributions can be divided into two types. One is discrete distributions, other one is continuous distribution. Under discrete distribution, in our syllabus we have two topics. One is binomial distribution and second one is Poisson distribution. And under continuous distribution, we have only one distribution, namely normal distribution. This is in our syllabus we have three distributions: binomial, Poisson and normal distributions. First one, binomial distribution. Binomial distribution. Definition: Bernoulli's trial. A trial which consisting of only two outcomes, namely success and other one is failure, is called a Bernoulli experiment. For example, in tossing of a coin, we can say that there are only two outcomes. One is getting head, other one is getting tail. If you consider getting head is treated as success and getting tail is treated as failure, so that experiment is known as a Bernoulli trial. If in an experiment, if there exist only two outcomes, we say that it is a Bernoulli trial. Similarly, in finding the defective number of items in the production line, getting a defective item, or we may getting a non-defective item. In that case also you can observe that there are only two outcomes. That experiment or that trial is also known as Bernoulli trial. Right. Next, on coming to a small derivation, to find the probability of getting X successes out of n Bernoulli trials, with each success probability small p and failure probability q, is p of x is equal to x is ncx p power x q power n minus x, where x is equal to 0, 1, 2, so on n. Now I am going to use the small derivation. So let us assume a Bernoulli trial, that means it is consisting of only two outcomes, success and failure, and also consider the success probability small p and the failure probability small q. Also I am assuming that there are only x successes out of n trials. There are n trials, and I am going to find out the probability of getting x successes. So that can be classified into following types. First you may get success, and then you may get failure, and you may get success, failure, so on, failure, success. In this we have x successes and other remaining n minus x are failures. So to get the probability of these successes and failures, for each success probability small p and each failure probability q, and p, q, so on, q, p. So in this we have p into, so in this we have p into so on p, x successes, q, so on q, n minus x failures. So that is, we get p power x into q power n minus x. So this is the probability of getting x successes and n minus x failures in n trials to get x successes. So this is one combination of getting x successes out of n trials, and there are NCX combinations. So this is one way of getting x successes and n minus x failures, and these combinations you may get NCX. So the total probability of getting x successes and n minus x failures is given by P of x is equal to NCx P power x Q power n minus x, where x varies from 0, 1 to so on n. The upper limit is n, because you may get 0 successes or 1 success or 2 successes, 3, 4, so on you may get n successes. So this is the probability of getting x successes in n trials, n Bernoulli trials. Right. Now, on coming to the definition, probability density function of a binomial distribution. How we define the probability density function of a binomial distribution? A random variable capital X is said to follow binomial distribution. Random variable is a discrete random variable. If it follows the binomial distribution, if its probability density function will be in the form P of x is equal to NCx P power x Q power n minus x, where x varies from 0 to n, otherwise the value is equal to 0. So here we say that P is the probability of success, probability of getting success. Similarly, Q is probability of getting failure, and n is equal to number of trials, and x is equal to number of successes, and P plus Q is equal to 1. Here, small n and small p are called the parameters of the binomial distribution. NP are called the parameters of binomial distribution. That means if you know the values of n and p, you can find the entire distribution. And we use the notation here, x approximates to b n comma p, to denote the random variable x follows binomial distribution with the parameters n and p. This is the notation, x approximates to n b 16 comma half and then it means that n value 16, p is equal to 1 by 2, then automatically q will become half, then you can find the required probability whatever you want. So n comma p are called here the parameters of the distribution. And also we can see that the sum of all probabilities in any distribution is 1. We know that the sum of all probabilities is 1. In binomial distribution also we can show that the sum of all probabilities is equal to 1. So that I can show that, note, probability of x is equal to x summation. The sum of all probabilities is equal to summation. Probability of x is equal to x is PDF. We know that NCx P power x Q power n minus x, where x varies from 0 to n. So on putting x values, the first value NC0 P power 0 Q power n plus NC1 P power 1 Q power n minus 1 plus so on NCn P power n Q power 0. So the whole thing can be written as Q plus P whole power n. So but Q plus P is sum of all probabilities, success and failure, that is equal to n 1. So 1 power n is equal to 1. So here also in this distribution also you can observe that the sum of all probabilities is equal to 1. Now the conditions of binomial distribution, when we can apply the binomial distribution. The binomial distribution can be applied to the given case under the following experimental conditions. The first one is n should be finite. The parameter n should be finite. N value finite, otherwise you cannot find the probability using this distribution. N should be finite, n never be infinity. Similarly, the constant probability of success P, the constant probability of success P is constant for each trial. That is the second condition. The third condition, the trials are independent to each other. trials are independent. The trials are independent to each other. And the last one is each trial consisting of two mutually disjoint events, namely success and failure. Success and failure. So in these conditions only we can apply the binomial distribution. Now, to find the mean value of the distribution, mean of the distribution. So we know that the mean formula for any distribution, mean is denoted by expected value of x, that is summation x into the probability density function. P of x is equal to x. So here summation x0 to n x into ncx p power x q power n minus x. This is summation x0 to n x into ncx means n factorial by x factorial into n minus x factorial into p power x into q power n minus x. Now on expanding the factorials, I can write n factorial as n into n minus 1 factorial. This is x into x minus 1 factorial. N minus x factorial can be written as n minus 1 minus of x minus 1 factorial, and p power x is p power 1 into p power x minus 1, and q power n minus x I am writing as p power n q power n minus 1 minus of x minus 1. So now I change the limit 0 to n as 1 to n because the negative factorial is not allowed. So I change the limit 0 to n as 1 to n. Now xx gets cancelled. Here n and p are the constants which are independent of x. So I can write outside from the summation np into summation 1 to n minus 1 factorial by x minus 1 factorial into n minus 1 minus of x minus 1 factorial into p power x minus 1 into q power n minus 1 minus of x minus 1. So this is equal to, so np into, so I can write this is np into, so on expanding the summation, on putting x is equal to 1, the value x is equal to 1 to n minus 1 factorial. So I am writing this as one step. X is equal to 1 to n. This whole thing can be written as n minus 1 cx minus 1 and p power x minus 1 q power n minus 1 minus of x minus 1. So on expanding, n minus 1 c0 p power 0 q power n minus 1 plus x is equal to 2, and substituting n minus 1 c1 p power 1 q power n minus 2 plus so on n minus 1 c x place lo n raste n minus 1 p power n minus 1 q power 0. So the entire term in the bracket can be written as q plus p whole power n minus 1. So this is, but q plus p is equal to the sum of success probability and failure probability is equal to 1. So this is 1 power n minus 1, that is equal to np. So mean of binomial distribution is equal to np. That is the first result. So next item is variance of binomial distribution. I would like to show that the variance of binomial distribution is equal to npq. So now the derivation, we know that the formula for variance is equal to expected value of x square minus e of x whole square. In any distribution, the variance formula will be e of x square minus e of x whole square. We know that e of x is equal to mean, that is equal to np in binomial distribution. The second term, okay, no problem. So now our aim is to consider the first term. So consider e of x square, expected value of x square. So that is equal to summation x square into the probability density function of the variable x, p of x. So to expand, for our easy convenience, I am writing x square as x into x minus 1 plus x. So the value x square minus x plus x will give x square, and this is p of x. So that is equal to summation x into x minus 1 into p of x plus summation x into p of x. So call this is equation number 1. And here the second term will be np. Again it is the mean of the distribution, that is equal to np. Only the first term will be to be evaluated. So that is sigma x is equal to 0 to n x into x minus 1 into ncx into p power x into q power n minus x plus np. Now on expanding this one, so sigma x is equal to 0 to n x into x minus 1. So what is the expansion of ncx? N factorial by x factorial into n minus x factorial, p power x as it is, q power n minus x plus n into p. Now I am expanding n factorial. So n factorial can be written as n into n minus 1 into n minus 2 factorial by x factorial, x into x minus 1 into x minus 2 factorial, and n minus x factorial can be written as n minus 2 minus of x minus 2 factorial into p power x can be written as p square into p power x minus 2. That will be remains p power x. And q power n minus x can be written as q power n minus 2 minus x minus 2 plus np as it is. So now here I am writing the limits 0 to n as 2 to n. So because I put if it is 0 to n, the value will be negative factorial, which will not be allowed. So I am changing the limit as 2 to n. So here x minus 1, x minus 1 gets cancelled, n minus 1 p square, all are constants. I can write outside of the summation n into n minus 1 into p square summation 2 to n. Here n minus 2 factorial by x minus 2 factorial into n minus 2 minus of x minus 2 factorial. This whole thing can be written as n minus 2 cx minus 2, right? I can write n minus 2 cx minus 2, n minus 2 factorial by x minus 2 factorial into n minus 2 minus x minus 2 factorial into p power x minus 2 into q power n minus 2 minus of x minus 2 plus np. So this is equal to n into n minus 1 into p square. So this whole thing can be the expansion of q plus p whole power n minus 2. So then I can expand. This is n minus 2 c0 p power 0 q power n minus 2 plus n minus 2 c1 p power 1 q power n minus 3 plus so on, plus last term I am putting x is equal to n minus 2 cx minus n minus 2 p power x place by n raste n minus 2 into q power 0 plus np. That is n into n minus 1 into p square. So the bracket lo in the entire term q plus p whole power n minus 2 plus np. But what is q plus p? q plus p is equal to 1. We know that q plus p is equal to 1. So the value becomes n into n minus 1 into p square plus np. This is expected value of x square. Call this is equation number 2. Now I am going to substitute this equation 2 in equation 1. So what is equation 1? What is equation 1? Variance is equal to, now I am substituting equation 2 in 1. Now substitute equation 2 in 1, then variance of x is equal to e of x square value n into n minus 1 into p square plus np minus e of x whole square. E of x we know that np, that is np whole square. So expanding n square p square minus np square plus np minus n square p square. So n square p square gets cancelled. So np on taking outside 1 minus p. But 1 minus p, what we know that q plus p is equal to 1. So the q value becomes 1 minus p. So this is equal to q. This is variance of the binomial distribution. The variance of the binomial distribution is npq. Similarly, we can find the standard deviation also. So the standard deviation is equal to positive square root of variance, that is equal to plus root of npq. So root npq is the standard deviation for the binomial distribution. Problems in binomial distribution. If a coin tossed 6 times, find the probability of getting 5 heads. So here you can assume that the experiment is a Bernoulli experiment, because in tossing of a coin there are exactly 2 outcomes. One is getting head and the other one is tail. Getting head, getting tail. It's 2 outcomes, so we can assume that it is a Bernoulli trial and we can apply binomial distribution. And we know that by binomial probability law, the probability of getting x successes by binomial probability law, the probability of getting x successes in n trials is ncx p power x q power n minus x, where x is equal to 0, 1, 2, so on n. Here in the given problem, the value n is equal to 6, the total number of times conducted the experiment, and the successes x is equal to 5 heads. Our requirement is we are supposed to get 5 heads out of 6 trials, and here the probability of getting head is equal to small p is equal to 1 by 2, then q automatically the value 1 minus half, that is also 1 by 2. Now our required probability, the required probability is probability of x is equal to 5. Our requirement is 5 heads. So the formula 6c5, p means 1 by 2 whole power 5 and 1 by 2 whole power 6 minus 5. So 6c5 is nothing but 6c1 and 1 by 2 whole power 5, and this is 1 by 2 whole power 1. So 6c1 6 and 1 by 2 power 6. So 6 into 2 power 6 into 64, 1 by 64, 2 3s and 2 32s. The required answer is 3 by 32. Next, the second problem. 10 coins are thrown simultaneously. Find the probability of getting at least 7 heads. So here n is equal to 10 and x is equal to minimum 7. Minimum 7 means x may be, number of heads may be 7 or 8, 9 or 10 coins, 10 units. And here the constant probability of getting head success is equal to 1 by 2 and q also 1 by 2. By binomial probability law, the the probability of getting x heads out of n coins is equal to ncx p power x q power n minus x, where x is equal to 0, 1, 2, so on, n. Here, probability of x is equal to x greater than or equal to 7. Our required probability is probability of getting x greater than or equal to 7, at least 7. That means you may get 7 or 8 or 9 or 10 coins, maximum limit 10. That means you need to calculate p of 7 plus p of 8 plus probability of getting 9 heads and probability of getting 10 heads. P of 7, p of x we know that ncx p power x q power n minus x. So p of 7 means 10c7, p and 1 by 2 whole power 7, and q also 1 by 2 whole power 10 minus 7, that is equal to 3. Similarly, second p of 8. P of 8 means 10c8 1 by 2 whole power 8 into 1 by 2 whole square. So next third term, and putting x is equal to 9, 10c9 1 by 2 whole power 9 into 1 by 2 whole power 10 minus 9, that is equal to 1. And the last value, when x is equal to 10, p of x is equal to 10 is 10c10 1 by 2 whole power 10 into 1 by 2 whole power 0. So 1 by 2 power 10, it is common term in all the terms. 7 plus 3 10, 8 plus 2 10, 9 plus 1 10, 1 by 2 whole power 10 10. So 1 by 2 power 10 I am taking outside, we will get 10c7 in first term, second value 10c8, third value 10c9, and last value 10c10. So in evaluating each term, 10c7 is nothing but 10c3. 10c7 is same as 10c3, that is 10 into 9 into 8 by 3 into 2 into 1. So 3 3s 9, 2 5s 10, 5 3s 15, 8s are 120. That is the first value. Similarly 10c8. 10c8 means 10c2. NCR is equal to NC n minus r, 10 minus 8, that is equal to 2. So 10 into 9 by 2 into 1, that is 45. 2 5s, 5 9s are 45. So 10c9 is same as 10c1, that is equal to 10. And the last value 10c0 is 10c10 is equal to 10c0, that is equal to 1. So on substituting all the values, the required probability, therefore probability of x greater than or equal to 7 is equal to 1 by 2 power 10 into 10c7 120 plus 10c8 45 plus 10c9 10 plus 10c10, that is equal to 1. So the value on adding, numerator 140, 165, 175, 176 by the denominator 2 power 10 is 1024. That value approximately 0.1719. Next problem. Determine the binomial distribution for which mean 4 and variance is 3. So in the problem, given mean and variance, we have to find the entire distribution. That means you have to show that this is in the form q plus p whole power n. You need to calculate p and q, then automatically you will get the distribution q, p, n. So given in binomial distribution, we have mean is equal to np, variance is equal to npq. Given np is equal to 4, mean is equal to 4, and variance npq is equal to 3. Now npq by np is equal to 3 by 4. So np gets cancelled. Q is equal to 3 by 4. So when Q 3 by 4, P is equal to 1 minus 3 by 4, that is 1 by 4. So we obtained the values P and Q, the remaining value N. So I am substituting in NP. Now NP is equal to 4, that is N into P means 1 by 4 into 4, which implies N is equal to 16. So we know N value, we know the P value, we know that Q value. Therefore, the binomial distribution is given by Q plus P whole power N, that is equal to 3 by 4 plus P 1 by 4 whole power 16. Right? So this is the required solution. Next problem. Mean and variance of binomial distribution are 4 and 4 by 3. So you have to find the probability P of x greater than or equal to 1. So to find the probability we require n, p, q values. So given np is equal to 4 mean and variance npq is equal to 4 by 3. Therefore npq by np is equal to 4 by 3 by 4, that is equal to 1 by 3. So therefore q is equal to 1 by 3 and p is equal to 1 minus 1 by 3, that is equal to 2 by 3. Also np is equal to 4, so n into 2 by 3 is equal to 4. So implies n is equal to 6. 2 2s are 4, 3 2s are 6. So we reached all the values n6, p 2 by 3, and q is also the value probability 1 by 3. Now by binomial law, probability of getting x heads p of x is equal to x is 6cx. N means 6cx, p power, p means 2 by 3 whole power x, into q 1 by 3 whole power 6 minus x, where x varies from 0 to 6. The upper limit is 6 because n is equal to 6. Now the required probability is, now probability of x greater than or equal to 1. So you are supposed to write x1, 2, 3, 4, so on up to 6. So instead of that I can write it as 1 minus probability of x less than 1. So this can be written as 1 minus p of x less than 1 means only value p of x is equal to 0. It is 1 minus p of x 0. I am putting x 0 in this. 6c0, 2 by 3 whole power 0, 1 by 3 whole power 6. So only one value. So I am simplifying 1 minus 6c0 1, 2 by 3 whole power 0 also 1, 1 by 3 power 6. So this is equal to approximately 0.9736. In a binomial distribution, if n is equal to 8 and also given that 4 into probability of x is equal to 5 is equal to p of x is equal to 3, find the value of small p, constant probability of success. So given n is equal to 8, also p of 4 into p of x is equal to 5 is equal to p of x is equal to 3. So from binomial distribution law, p of x is equal to 5 can be written as 8c5 p power 5 q power 8 minus 5, that is equal to 3. Similarly, here on the right hand side, N8, 8C3, P power x, P power 3, Q power n minus 3, that is 8 minus 3, that is equal to 5. So, and also since 8C5 is same as 8C3, so left hand term, right hand term, 8C5, 8C3 gets cancelled. 4 into P power 5 Q cube is equal to 8 P cube into Q power 5. So again it is 4 P cube gets cancelled, Q cube square, 4 P square is equal to Q square. That is 4 P square is equal to 1 minus P whole square, because Q is equal to 1 minus P. So 4P square is equal to, and expanding, 1 plus P square minus 2P. So in solving this expression, equation, 4P square minus 1 minus P square plus 2P is equal to 0. This is 3P square plus 2P minus 1 is equal to 0. P is equal to minus B plus or minus root of B square minus 4AC by 2 into A. 2 3s are 6. This is minus 2 plus or minus 4 3s are 12 plus 4, 16 by 6, or minus 2 plus or minus 4 by 6. First value minus 2 plus 4 by 6, minus 2 minus 4 by 6. So 2 by 6, 1 by 3, and this is minus 1. So P value is equal to 1 by 3. Therefore, P value never be negative. So P cannot be negative, since P value cannot be negative. So P value can be taken as 1 by 3, which is the required solution.